explain it, I think. So what we're going to look at is, in this very first example here, it says that you have a daily cost function for a given manufacturing firm is given by C of X equals 180X plus 200 on the interval 0 to 20. Okay, so first of all, what's the marginal cost? You guys remember that? It's the derivative, okay? So what's the derivative of the function I gave you? 180, right? So the marginal cost C prime of X is 180. Now what we're going to do is I've given you a couple of graphs on here. So this is the graph of the original function. This is the graph of the derivative 180. Okay, and we're going to kind of talk about what they mean in the context of area. So my question is, what is the change in cost as production changes from 5 units to 10 units? Well, what you'd have to do is you'd have to do C of 5, which would just be plugging into the original function. So we're going to do 180 times 5 plus 200. And let's see, that would be maybe 1,100. 180 times 5, yeah, that's 1,100. Okay. And then what we'll do is C of 10. So we plug into the function. So we got 180 times 10, and then plus 200 on that, and that would be 2,000. Okay, so that's what the production is. So I'm just plugging that in. Now what I'm saying is, what is the change in cost? So the change is just going to be equal to C of 10 minus C of 5, and C of 10 is 2,000, and C of 5 was 1,100. So what you end up getting is that's $900. Okay, now what that's attempting to show you in this graph is that would be this region right here. It's just the difference between these two Y values like that. Okay, now what we're going to look at is kind of what happens if you look at the marginal cost and look at an area under a curve. So the idea with this is the marginal cost is 180, and that is going to be the graph of a horizontal line. Okay, so if you did that, it turns out if you do this area, you get the same answer. Okay, which is kind of weird, because what you're really doing on this is you're doing base of 5, and then the height is going to be 180. So you're just doing the area is base times height. So the base, the distance between 5 and 10 is 5, and the height is the function value. So that gives you 900. So that's kind of bizarre that you get the same answer, but there's an important connection between the two. What you're going to find is they're going to have the same answer. So there's something I want you to write down on here. And really, this is kind of what this means is this, okay? So if you find the area under the curve, that would be the integral from 5 to 10 of 180 dx. Okay, now what I'm doing is I'm taking the area under that curve 180 like that. Okay, so that would be kind of what we're going to be looking at. Now what I'm going to show you next is kind of how to do the area under the curve. So it turns out that this area of the derivative under the curve of the derivative ends up being the same as this change in cost. All right. Now let's go to the bottom here, and the fundamental theorem of calculus is basically going to show you how to do what we call a definite integral. I haven't shown you how to do that yet. I just explained what a definite integral was. Okay, so let's go to the next page, and here's what the fundamental theorem is. Okay, so, and you don't need to write this down. I'm just kind of showing you what this formula is saying. So if you have an integral, a to b f of x dx, what you end up doing is you do the antiderivative and subtract these. I did that backwards. Oh my God, that's horrible. Okay, change that, please. That's f of b minus f of a. When I was typing that out today, that was totally wrong. So change that fundamental theorem. You always do the antiderivative of the upper limit minus the antiderivative of the lower limit. Okay, and that antiderivative is capital we use a capital to represent that antiderivative. So what the problem is really saying is you already know how to do an antiderivative. That's what an integral is doing. But what you do is you plug in the b into the antiderivative and the a into the antiderivative, then you subtract the result. And I'll show you why you subtract. The example 2 below is an easy way to explain that. Okay, so let's go down to the bottom here, and then this will begin to make a little more sense once I show some examples on here. So what we're going to do first of all on this problem is we're just going to graph y equals 5. Now we're not going to do this on the calculator because y equals 5 is a horizontal line. So just go ahead and draw that horizontal line. That's the graph of y equals 5. Okay, now in this definite integral, you're going from 2 to 8. So just kind of highlight 2 and 8. And then what we're going to do, I'm going to use a little dashed line here. And then I'm going to shade in that region right here. So this definite integral, what it's doing is it's doing the area under that curve. And you can find that because it's a rectangle, right? It's just one big rectangle. So when I'm looking at this problem, the shape that we're finding an area of is a rectangle, and the formula is the area of a rectangle is base times height. Okay, so we're just going to do the area on this. So the base is going to be the distance from 8 to 2. So you're just going to have a base of 6. What's the height? 5. Okay, so you're going to have 6 times 5 equals 30. So that's what the area under that curve is without using calculus, okay, because it's just a rectangle anyway. So the base is 6, and then the height is going to be 5, okay? It's just one big rectangle. Now what I'm going to do is I'm going to teach you how to do the fundamental theorem of calculus and just show you that it gives the same answer anyway, okay? All right, so here's kind of what you want to do. We're going to, first of all, just go ahead and write down the integral, 2 to 8, 5 dx. Okay, what is the antiderivative of 5? 5x, right? So you write down the 5x, that's the antiderivative. Now, generally what you do is you put a bar and then you put 2 to 8. That's shorthand notation, okay? So we're just doing the antiderivative. Now, here's what's new. What you do is you plug in the upper limit, you do 5 times 8, and then you plug in the lower limit, so you do 5 times 2, and then you subtract. The fundamental theorem basically just says take the antiderivative, evaluate the upper limit, the lower, and find the difference. So what we get is we get 40 minus 10 equals 30. Isn't that cool? It's the same dang answer. How about that? Now let's look at why that is. Okay, so what that's going to do is this fundamental theorem is going to give you the exact answer. Now, what I want to do is show you something. You don't need to necessarily write this down or anything, but I want to show you kind of the significance of these numbers right here, that 40 and 10, and what they really mean. So what you're really doing on this, that 40 actually comes from this entire area right here. That's what that's doing. Isn't that area of that yellow rectangle 8 times 5 or 40? Right? The area of that thing right there is 40. So what you're really doing is you're really doing the integral from 0 to 8, which is like the big area. And then what's going to happen is this 10 right here is this. The 10 is this thing right here. Okay? Because that's 2 times 5. It's base times height. So what you're doing on this is you're doing the area from 0 to 2, and that's the small area. Now, the reason you're subtracting is because that would give the leftover area. Now, I want you to try to wrap your head around this. So the idea is the big area is here, that whole yellow thing. Then there's that green area. If I take the big minus the part, wouldn't that give you the leftover area? Okay. So that's what the fundamental theorem's doing, is it's just always going from 0 to that thing, and then it's going 0 to that thing, and it's subtracting to get the leftover area. Does that make any sense? Okay, that's the idea. It's just kind of like the big area minus the part gives you the rest. So that's a good way at least to show students how that, why we subtract. Okay, so get your calculator out. The next thing I want to show you is how you can do a definite integral on your calculator. And then we'll finish up class probably with maybe one more example here, just so that we're started. Okay, so go ahead and put 5 in. Just go ahead and graph, go to y equals and just put 5 in. And for a window, go 0 to 10 on the x-axis, and then go 0 to 10 on the y-axis. Okay, because I want you to just graph the same thing as what I gave you. Okay, then type graph, and you got that. Now, these keystrokes that you see at the bottom of the page will show you how this works. And this is cool, man. I can hardly contain my excitement. So what you do is you go second trace, and then this time you go all the way down to option 7. See, there's an integral right there. Okay, you press enter like that. Now what you do, it's going to ask for the lower limit. The lower limit is 2. Going back to the original problem, you type 2 in, press enter. Now it's going to ask for the upper limit, which is 8. Now look what it does. Ooh, I knew you would be impressed by that. Woo. Okay, so it does that. So actually, like the last web work assignment you're going to do is definite integrals. I couldn't keep you from doing every single problem on your calculator. On the final exam, you want to know how to show your work and do a couple of definite integrals, but you can do it on your calculator. Okay, and I mean it'll give you it'll even shade that area, and you can learn to do it that way, certainly. Okay, well, let's do just kind of like one more problem and put this together. Go ahead and get your calculator, and what I want you to do on this example 3 is just put in graph 2x plus 3, and just use the same window that we did for the previous problem. Okay, and that's okay on that. What I'm going to do is go to my table of values and just get a few points on here, and this will be fine. So let's just do take the point like 2, 7 and plot that, and then take like the point 4, 11 and maybe label those 2 points. So that's 4, 11, and then this point right here is 2, 7. I'm just getting that information from the graphing calculator. Then you can go ahead and just kind of connect the line. Doesn't have to be perfect. Okay. So that's a line, and what we can do on this is we're doing the integral from 2 to 4. So what you want to do is just go to 2 and 4 and go straight up to the curve like this. And then we're going to shade in the area, the region that we're going to be finding the area of. So in this problem, this definite integral is giving us that area. Now that's an area you learn how to do at some point in time. I don't know when, high school or something, I don't know. But this shape is called, does anybody know what this shape's called? It begins with T. Trapezoid. It's what we call a trapezoid. And what a trapezoid is a trapezoid is a four-sided figure where two opposite sides are parallel and the other two are not parallel. So like these two sides right here are parallel, okay? And there's a formula for it, and the formula is area equals the height times the sum of the bases. Okay, so I'm just going to show you how to do this with the geometry formula. So what you would have is this base right here. I will call that B2. And the base is, it doesn't mean top and bottom. It means the length of the parallel sides. So that's 11, because that y value is 11. This part right here, this side would be base 1, so that's equal to 7. Okay, like that. Okay, and then the height is not how tall it is, it's how far apart are the parallel sides. So in this case, the height is 2. Okay, so what we're going to do is work out 2 times 7 plus 11. So that gives 2 times 18. So that's going to be equal to 36. So that would be the exact area under that curve. That's a trapezoid. Okay, you have to know that formula to do that. So let's finish up just by doing the fundamental theorem of calculus. Okay, so here's how you do this now. All right, so how do you do the antiderivative of 2x to the first? Power rule, 2x to the second over 2. Okay, 2x to the second over 2. What's the antiderivative of 3? 3x, and then put your bar and then put the 2 4. Okay, and then we can kind of use the calculator to help us a little bit. So you do the antiderivative. Now those 2's are going to cancel out. So what you're really doing is x squared plus 3x from 2 to 4. Well, what you do is you plug in the upper limit. So you're going to plug in the 4. So you're going to do 4 to the second plus 3 times 4 minus, and then 2 to the second plus 3 times 2. So you plug in the upper limit and the lower, and you subtract in that order. Okay, so this is probably easy enough. I can do it in my head. This would be 16 plus 12. This would be 4 plus 6. So this would be 28 minus 10. Oh, crap. Oh, crap. I know what I did. Okay, I was going too fast on that trapezoid thing. Okay, I got 36 and 18. I gave you the wrong formula for the trapezoid. The trapezoid is 1/2 the height times the sum of the bases. Okay, so what you'd end up doing, let me correct this. I don't know, I believe I did that. Okay, so you would end up kind of doing this, and I'll clean this up a little bit. So what you have on your trapezoid, we should have done 1/2 times the height, which is 2, times the sum of the bases, 11 plus 7, those would cancel out, that would give 18. They're the same, okay? So when you do that definite integral, it's always going to give you that same area, okay? Now what's going to happen is once you learn how to do the definite integral, then you can find the area without even having to graph or anything, okay? So what we're kind of getting at to kind of start wrapping up is when you do a definite integral, you do the antiderivative, then you plug the limits in. Does that make any sense? Yeah. That's a part of the formula. I wrote that down wrong. The formula for a trapezoid is 1/2 the height times the sum of the bases. I don't know why it did that. Okay, that's why. I was expecting the answer to come out the same, and I knew they would come out the same, so then I immediately knew I had the wrong formula. Okay? Okay, all right, so we'll wrap this all up next week. Yeah, there's 2 more on WebWork. The one that will be due Tuesday is 3.01. They're fairly short, too. They're not real long sections where you're doing the definite integral properties, all the same kind of problems you did in class today. Okay? All right? And then 3.02 will be due next Thursday, and it's all going to be definite integrals. And I think what I would suggest you do on that is do 2 or 3 of them by hand. And if you run out of time, you can do some of them on the calculator, too. Okay, the way I showed you, okay?
Yeah, that's your
So be sure you work on that extra credit.
Yes.
You got the 3 tests now, so.
Yeah. I'm like.
Looks like we just need to maybe get some help on getting ready for the final. Feel a little bit better.
Yeah.
So I would start as soon as I possibly can, go to D12 and look at the final review.
Yeah, you have to put enter or someone
No
more.
problems.
Do you believe I can pass? Okay. No, I'm not.
And I mean, it's like,
I was looking at the flyer.
I could probably even give you sort of a estimation of what you're shooting for.
I'll probably be shooting for what, like 72?
You got, because I think your scores on the test were sort of similar.
Yeah, so.
Okay.
And I don't really see how it relates to the account. It was going to tax. But I don't know if I want to.
You're within striking distance for sure. So your first test is actually the lowest. So
Yeah, I'll let you know.
yeah, 65, you probably do it. 65 on the final would probably do it. Roughly.
Roughly?
Yeah.
And if I do better?
Well, it would solidify.
Yeah.
You see, I don't know. So if you're thinking about B, you'd have to knock it out of the park. It's still possible, though.
It just makes you once again. That's why
You'd have to probably be way up
No,
there.
you're right.
You'd probably make an A on the final. But if you made an A on the final, it would give you 2 A's on your test. It'd probably pull you out.
So, okay, so I have to put all of my work into that final exam. Okay.
That's at the finish line, so you're running as hard as you can, so it's possible to do that. Okay.
All right, and then, is there any chance that you could open a quiz 5 for me?
Yeah.
I think I accidentally closed it and it reached my time limit.
Okay. Yeah, I'll do that right now.
Okay. As long as I believe myself, as long as you think you can do it.
What's that?
As long as you think you can do it, I think.
No, I know you can do it. Okay, I know you can do it. And this calculus is not easy.
No, for me, it's.
Yeah.
You know, it's just, and it's tests that you've had a little bit more trouble with, and that's pretty common.
It took IB calculus in high school. I failed that my first semester. I ended up having to do like test corrections to pass the first semester on top of work for the second semester.
Yeah, so you kind of got out of there just kind of
Yeah.
halfway with test corrections, pulled you out. Yeah.
Yeah.
Well, you've learned a lot, and you made good progress, and we can get this done and wrapped up, and you don't have to worry about maybe any more math. Which is kind of sad, isn't it? Yeah, it can be kind of sad.
I mean, I may not be like the best at math, but like I actually enjoyed it.
Yeah, that's interesting. I mean, it does a lot of interesting things, so you got a good attitude for it. That's good. That's a good thing. All right. So what'd you say? Quiz 5, I'll open it up right now. Okay?
Thank you so much.
Yep.
I have that answer right there.
Oh, I just didn't have one part because I was like, why this one is not working out, so it's, I have this one.
That one X is gonna be 5.
Here, yeah, I don't know.
Alright. Yeah, it took me a second to figure it out too, but.
I missed, quiz number 6, because I didn't see it at the bottom.
Okay, I'll open it up. So I got quiz 6. Okay.
I don't know, it's confusing because.
Those quizzes show up at the bottom of the page. I think there's a way to order it differently, but it's kind of a pain. But I'll set it up.
I got a lot of study into that one stuff because I get my associates in May, so I was like, oh, this is going to do something. And I go to Metro. Yeah, I'm gonna go for my master's. So.
Do you know where you're going to go yet, Roman?
Metro State, sir.
Okay.
Yeah, I've already talked to him. I'm already still there to start a fall.
Then you won't have to take their business calc over there. That's good.
Oh yeah. Yeah, no, that's like.
I told you guys, I'm afraid I'm just going to have people, nobody's going to want to take this class anymore. Man, you need to take it here. Yeah. Yeah, you can. Yeah, we have interinstitutional registration.
A lot of the professors here, like, they teach at like CU and Metro.
Well, I taught at CU for 20 years, just, you know, so I don't do it anymore because I'm making big bucks now. I'm like getting close to retirement, so. That's right. It's just, you know, I can't lose my job unless I do something really seriously bad.
Oh, okay. Okay, appreciate you.
Will we have like a web work or WebEx for the final or no?
What's that?
Will we have web work for the final?
You mean a review?
WebEx.
Yeah, like me, I always get the two things. Yeah, I'll do a couple of reviews.
Okay.
I haven't decided when I'm going to do them yet, but I'll do them. All right.
Thank you guys.
All right. Have a good weekend. So quiz 6.
Yeah,
Okay, I'll set it up.
thank you.
All right. Just
I forgot to put charger here.
Oh, okay. Yeah, so I got your quiz set up.
Thank you. Have a good weekend.
All right.
that's for you. Ready to wrap it up? Yeah, I know, she's busy. Yeah.
And Nah. out.